Good evening. We must begin with comet Catalina, which made its close approach to the Sun on the 15th of November and has now become visible in the morning sky. During December, it passes through the constellation of Virgo while brightening to naked eye visibility. On New Year's Day, it will be less than 2 degrees from the bright star Arcturus in Bootes, the herdsman. It is a green comet like Pan-STARRS, and binoculars is all that you will need to see Catalina in splendid detail. There are also 3 bright planets on view in the southeastern sky before sunrise: Venus, Mars and Jupiter, which are splendid sights in small telescopes. Venus is the second planet out from the Sun and therefore shows phases like the Moon. These images of the planet were taken on the 8th of November by Italian astrophotographer Stefano Carissima. They show Venus near half phase. In the months ahead, its disk will grow to full, while the planet's apparent size will shrink. Superior conjunction, full phase, will be on the 6th of June 2016. Mars, at magnitude 1.4, lies in the constellation of Virgo. The planet is far away at the moment, so its disk is quite small. Here is another image from Stefano Carissima showing the red planet. Mars comes to opposition on the 22nd of May 2016, when it will be nicely placed for observation. Jupiter shines brightly at magnitude -2.2 and lies below the main body of Leo, the lion. This image by Australian photographer Trevor Berry shows the planet nicely. Its cloud bands can be seen in small telescopes, while its 4 large moons, Io, Europa, Ganymede and Callisto, can be seen even in a pair of binoculars. The winter season begins on the 22nd of December, and the conspicuous constellations of Orion, Taurus, Gemini and Canis Major are on view once more. As seen by amateur astronomers living in the Northern Hemisphere, they are our celestial friends. For observers in the Southern Hemisphere, where it is now summer, the familiar constellations of winter appear upside down, and they are over the northern horizon, while other constellations are on view that can never be seen from our northern shores. In the Northern Hemisphere, the 7 bright stars of the Plough, Ursa Major, the Great Bear, can be seen in the northwest, standing on its handle. We are fortunate to have this signpost, as the upper 2 stars in the bowl, Merak and Dubai, are known as the pointers because they lead the way to Polaris, the pole star, in the tail of Ursa Minor, the Little Bear. In the Southern Hemisphere, there is no such pattern of stars, and the south celestial pole is not marked by any bright star. The constellation that marks the south polar sky is Octans, the octant, whose stars are no brighter than the 4th magnitude. Before we view the stars of the southern skies as seen from latitude -35 degrees south, we need to work out our star horizon. It's quite easy to do. I live in Nottingham, in the UK. The latitude of my observatory is plus 53 degrees 46 minutes. For simplicity, let's call this 54 degrees. The pole star, as seen from Nottingham, is therefore 54 degrees above the northern horizon. Take 54 from 90, which gives us 36. This tells us that stars and objects with a declination of plus 39 degrees will never set from Nottingham. They will go round and round the pole and are said to be circumpolar. Any star or object with a declination of -35 degrees will never rise above the southern horizon. and stars with a declination greater than minus 34 degrees will be increasingly visible from my home. So, where you live on the Earth, you can easily work out what constellations and stars can be seen from your home. Let us now travel to Adelaide in Australia, where the latitude is minus 35 degrees south, and see what our southern hemisphere friends can see in the January night sky. I have selected January partly because it is the beginning of the year, and partly because both our main guides, Orion and the Cross, are now on view. Orion is not far from the zenith, or overhead point, so let us deal with that first. The familiar winter constellations we are used to in the northern latitudes are now upside down in the northern sky. So Sirius the Dog Star is high up, while Aldebaran in the Eye of the Bull is low down. Rigel is now top left in Orion, while Betelgeuse is in the bottom right of the figure. Orion is very easy to recognize because its 7 main stars are so brilliant and make up so a characteristic pattern. Beta, or Rigel, and Alpha, Betelgeuse, are among the brightest of the first magnitude stars. Then follow Gamma, Bellatrix, Epsilon, Alnium, Zeta, Alnitak, Kappa, Psi, and Delta, Mentaka, all of which are between magnitudes 1.6 and 2.2. Of the two leaders, Rigel is the brighter and should logically have been lettered Alpha rather than Beta. It is a true celestial searchlight, 60,000 times more powerful than the Sun. Its distance is about 900 light years, so that we are now seeing it as it used to be when William the Conqueror ruled England. When seen through binoculars, it is magnificent, and it has a 7th magnitude companion at a separation of between 9 and 10 seconds of arc. Betelgeuse is as different as it could possibly be. Here we have a red supergiant well past its prime of life and experiencing its last period of glory before disaster overtakes it. In sheer power, it cannot compare with Rigel, even though it could match 15,000 suns, and its surface is relatively cool, hence its orange-red colour. But what it lacks in temperature, it makes up for in sheer size. Betelgeuse is decidedly variable. It is an unstable star. It swells and shrinks, changing its output as it does so. The magnitude is generally about 0.5, but there are times when it rises almost to the same magnitude with Rigel, while at minimum it is not much brighter than Aldebaran in Taurus. It is classed as a semi-regular variable with a period of about 5.7 years, but this period is very rough indeed. Its fluctuations are slow, but can be followed with the naked eye. The method is to compare Betelgeuse with other bright stars, mainly Procyon in Canis Minor, which is 0.4, Aldebaran 0.8, and of course Rigel, which is of magnitude 0.1. Some allowance must be made for what is termed extinction. A star which is low on the horizon will be dimmed because more of the incoming light is absorbed by the atmosphere. In making comparisons, always try to select a comparison star which is about the same altitude as the variable. According to the Cambridge catalogue, Betelgeuse is 310 light-years away. This means that it is only 1/3 as far from us as Rigel, and there is absolutely no real connection between the two. Modern techniques have made it possible to identify a certain amount of surface detail on it, though ordinary telescopes show it only as a speck of light. The other main stars in Orion are very hot and bluish, all very luminous. Psi seems to be about 50,000 times as powerful as the Sun. Look next to the sword, which extends upward from the 3 stars marking the Hunter's Belt. Alnitak, Alnium, Amentaca. Here we find the great nebula, Messier 42, which a small telescope will show the four main components of a trapezium, Theta Orionis, which makes the nebula shine. Closer to Alentac is a small dark gas patch known as the horse's head from its outward resemblance to the head of a knight in chess. It is not particularly difficult to photograph, but is remarkably elusive telescopically. The hunter's retinue are on display, and pride of place must go to Sirius in Canis Major, the great dog, which shines as the most brilliant star in the whole night sky. To locate it, start at the belt and follow the line upward, but no guide should be needed because Sirius stands out because of its sheer brilliance. It is one of the closest stellar neighbours at a distance of only 8.6 light years. It is 26 times as luminous as the Sun. This is puny in comparison with Rigel, and Sirius is not so imposing as it looks. In colour, it is pure white, but when low over the horizon, it seems to flash all colours of the rainbow. Even when high up, as on the summer evenings, it still twinkles quite noticeably. In fact, star twinkling is due entirely to the Earth's dirty, unsteady atmosphere, and is nothing directly to do with the stars of summer evenings themselves. Go beyond the top of the atmosphere, to the moon for example, and the stars will appear as hard, steely points, without the slightest tendency to shimmer or flicker. From Earth, Sirius is the supreme twinkler, merely because it is so brilliant. Sirius is not a lone traveller in space. It has a faint white dwarf companion as massive as the Sun, but no larger than a planet such as Uranus. The orbital period is 50 years. Because Sirius is often called the dog star, the companion is nicknamed the pup, but it is a very substantial pup indeed. There is a minor mystery associated with Sirius. Some of the old astronomers of classical times described it as being red. This is certainly not true today, despite the twinkling, and it is not likely that there has been any real alteration, because Sirius is a perfectly stable main sequence star. Suggestions that the pup may have been a red giant not so long ago can be ruled out, mainly because the timescale is all wrong. We have to conclude there has to be some error in observation or interpretation. All the same, it is decidedly curious. Canis Major contains several bright stars as well as Sirius. Epsilon, Adrara, magnitude 1.5, Delta, Weathera, 1.9, Beta, Mersam, 2.0, and Eta Olodra 2.4. All are very remote and luminous, so they far outshine Sirius. Weather may be 130,000 times as powerful as the Sun, but is only 300 light years away. There is also a fine open cluster, Messier 41, which lies close to Sirius. It is visible with the naked eye as a hazy patch, and binoculars show it really well. Canis Major can be seen here, together with two of its smaller neighbours, Columbia the dove and Lepus the hare, neither of which is of particular note. Now let us return to Orion's belt and follow the line downward. This time it will reach the orange-red first magnitude star Aldebaran, the eye of Taurus the bull. Superficially it looks very much like Betelgeuse, though it is neither so large, so remote, or so powerful. Extending away from it is a V-shaped cluster of Hyades, and on the far side of Orion we come to the Pleiades, or Seven Sisters, which were of such significance to the Maori. On the next clear night, count the number of Pleiades you can see with the naked eye. The record held by a last century German astronomer named Eduard Heiss is said to be 19. Taurus is not a constellation with a distinctive shape, but it does contain one other bright star, Beta Tauri, or LNEF, magnitude 1.6. LNEF was formerly included with Auriga as Gamma Auriga, and there seems to be obvious reasons for its free transfer to the Bull. Lambda Tauri is an Algol-type eclipsing binary with a magnitude range of 3.3 to 4.2 and a period of 3.9 days. It can be found by using the V formation of the Hyades as a sort of arrowhead. Useful comparison stars are Gamma 3.6, Xi 3.7 and Mu 4.3. The Crab Nebula, known to be the remnant of a supernova of 1054, lies close to the third magnitude star Zeta Tauri, or L-Heca. It can just be seen with powerful binoculars. Outwardly, it may look dim and uninteresting, but to astronomers it is one of the most important objects in the sky, because it radiates over a whole range of wavelengths. In Charles Messier's catalogue, its nickname of the crab was bestowed on it in 1845 by the Earl of Rosse, who examined it with his great homemade 183 centimetre, about 72-inch reflector at Bear Castle in Ireland. Next in our catalogue of Orion's retinue comes Auriga, the charioteer. It is easy to locate because it contains one exceptionally brilliant star, Capella. In case of difficulty, take a guideline from Mintaka in the Hunter's Belt through Bellatrix. Auriga can attain a reasonable height during summer evenings from most of Australia and South Africa. Look for it in the north, but from New Zealand it is always inconveniently low. Capella is a yellow star. Its surface temperature is much the same as that of the Sun, but whereas the Sun is officially ranked as a dwarf, Capella is a giant with luminosity around 150 times that of the Sun. It is actually a very close binary, but the components are only 177 million miles apart, and in ordinary telescopes, Capella looks single. Its distance from us is 42 light years. Adjoining Capella is a triangle of three fainter stars, Epsilon, Eta and Zeta Aurigae, known collectively as the Hoidi or the Kids. Capella has been known as the goat for centuries. One member of the trio, Eta, is an ordinary bluish-white star, 400 times as luminous as the Sun, but the other two are remarkable objects. Both are eclipsing binaries, though they are not in the least alike. Zeta Sagittarius has a range from magnitude 3.7 to 4.2. Eclipses occur every 972 days. The main star is an orange K-type supergiant whose colour is obvious in binoculars. The companion is a hot B-type star. The distance from us is nearly 700 light years. Epsilon Aurigae is even more unusual. Here we have a particularly luminous supergiant, perhaps over 60,000 times as powerful as the Sun, lying at a distance of 4,600 light years. The eclipsing companion has never been seen, and as it did not periodically pass in front of the supergiant, we know little about it. We are not even sure of its nature, for most astronomers think it must be a small hot star surrounded by a large spurious cloud. The period is 27 years, and eclipses last for a very long time. The extreme range is from magnitude 2.9 to 3.8, and Eta makes a convenient comparison star. The rest of Auriga is fairly prominent. Beta Menkaurina is of the second magnitude. Theta Iota between magnitudes 2 and 3. There are also three fine open clusters, Messier 36, Messier 37 and Messier 38, all of which are binocular objects. And in Auriga, the Milky Way is very rich. The last two members of Orion's retinue are Gemini the twins and Canis Minor, the little dog. Gemini is marked by two bright stars, Pollux, magnitude 1.1, and Castor, 1.6, which lie side by side. You can find them by using Rigel and Betelgeuse as pointers. In mythology, they were two twins. Pollux was immortal, while Castor was not. When Castor was killed in battle, Pollux was pleased to be allowed to share his immortality with his brother, and both heavenly twins were placed in the night sky. Though lettered Beta, Pollux is the brighter of the two by half a magnitude. Castor and Pollux are not generally associated. Castor is 46 light years from us, Pollux is only 36 light years. Pollux is a single star of type K, clearly orange in colour and 60 times as luminous as the Sun. Castor is white and is a multiple system. It is a fine double star. The components are of magnitudes 1.9 and 2.9 respectively, and the separation is between 2 and 3 seconds of arc. The orbital period is 420 years. Each component is again double, though too close to be split with an ordinary telescope, and there is a third faint companion which is also a binary, so that altogether Castor consists of 6 suns, 4 bright and 2 dim. The form of Gemini is distinctive, and the Milky Way flows through it, so there are always rich star fields, and there are 2 interesting variable stars. The semi-regular Eta, or Propus, which ranges between 3.2 to 3.9, with a rough period of 233 days, and Zeta Macbuda, which is a typical Cepheid with a range of between magnitude 3.7 and 4.1 and a period of 10 days. For these variables, you may like to have the magnitudes of some comparison stars. Mu, or T-Jet, is at magnitude 2.9 and is reddish. Nu, 4.1, Xi, 3.5, and Lambda, 3.6, and of course Delta at magnitude 3.5. There is also a splendid open cluster, Messier 35, close to Mu, and the variable Eta. It is on the fringe of naked eye visibility, and binoculars show dozens of stars in it, most of which are hot and white. Canis Minor contains nothing else of interest. The area between Procyon, Sirius and Betelgeuse is filled by a large constellation, Monoceros the Unicorn, which is rich in faint stars and lovely fields, but contains no bright star. If you extend a line from Rigel through Aldebaran and continue it as far north as you can, you will come to Perseus. It contains 1 second magnitude star, Myrfak, but is always very low because of its high northern declination, and from Invercargill it remains below the horizon. The most interesting object in Perseus is the prototype eclipsing binary Algol. The period is 2.87 days, and the range is from magnitude 2.3 to 3.5. It remains at maximum for most of that time. When it fades, it takes several hours to fall to minimum, and after remaining dim for 20 minutes, it brightens slowly up again. Of Algol's 2 components, the brighter is a B-type star, about 100 times as luminous as the Sun. The eclipsing companion is larger but less powerful, and the eclipse is not quite total. When the fainter star passes in front of the brighter, there is a very small dip in magnitude, but you will not notice this with the naked eye. Incidentally, the explanation of Algol's behaviour was discovered in 1783 by a most unusual astronomer, John Goddard, who was both deaf and dumb, and who died at the early age of 21. Let us now turn back to the southern aspect of the sky. The cross is rather low, and the pointers Alpha and Beta Centauri are not far above the horizon. They actually set from Brisbane and Johannesburg, but are circumpolar from Perth, Durban or anywhere further south, and of course from the whole of New Zealand. Arcana can be located by using the longer axis of the cross. The long constellation of Eridanus extends from the far south right up to Orion. Theta Eridani, or Arcana, is a fine, easy double. The components are of magnitudes 3.4 and 4.5, and the separation is over 8 seconds of arc. Both components are hot and wide with A-type spectra. Epsilon Eridani is much further north and only of magnitude 3.7, but it is less than 11 light-years away, and although it is much smaller and less powerful than the Sun, it is sufficiently solar to be regarded as a possible planetary centre. It was one of 2 stars to be studied by Frank Drake and his team in the regional hunt for extraterrestrial intelligence, though the results were negative. The high south is dominated by Argo Nevis, the ship Argo, which contains the brilliant Canopus. Argo has a dubious distinction of being the only constellation which has been officially chopped up because it was too large and unwieldy. In mythology, it was a ship which carried Jason and his companions in their quest for the Golden Fleece. Modern astronomers have divided it into Carina the keel, Vela the sails, and Puppis the poop, so Canopus, which used to be known as Alpha Argus, has become Alpha Carini. Here, the constellation is shown with the nearby star groups of Pyxis, the mariner's compass, Volans, the flying fish, and Pictor, the painter. For sheer brilliance, Canopus is inferior only to Sirius. Its magnitude is minus 0.7. To identify it, extend a line from Allantac in Orion's belt through Sciath, passing through Lepus and Columba, and finally arriving at Canopus. Canopus has an F-type spectrum, and in theory ought to be slightly yellowish. It is a cosmic searchlight, perhaps 200,000 times as luminous as the Sun, and squandering its fuel at an enormous rate. It is circumpolar from New Zealand, though from parts of Australia and South Africa it sinks briefly below the horizon during its 24-hour circuit of the pole. The richest areas of Argo are in Carina and Vela. Beta Carina, or Maya Placidus, magnitude 1.7, can be located by a slightly curved line from Beta and Alpha Cruxis. If sufficiently prolonged, the same line will eventually lead you to Canopus. Note also the false cross, made up of 4 bright stars, Kappa and Delta Velorum, magnitudes 2.5 and 2.0 respectively, and Iota and Epsilon Carina, 2.2 and 1.9. Unwary viewers have mistaken it for the real cross, and this is understandable because the shapes are the same. But the false cross is larger, less brilliant, and more symmetrical. Here too there is an interesting colour contrast. 3 members of the false cross are bluish-white, while the 4th and brightest, Epsilon Carina, is orange. The false cross can be used to find a fine open cluster, IC 2602, round Theta Carina. Use Delta Velarium and Iota Carina as pointers. Not far from Theta is the orange erratic variable Eta Carini, which was once even more brilliant than Canopus, but is now just below naked eye visibility. Binoculars are powerful enough to show its colour, and telescopically it looks rather like an orange blob, quite unlike an ordinary star. At its peak it was perhaps 6 million times more powerful than the Sun, and this is still true today, though its brilliance is dimmed by intervening nebulosity. In infrared light, it is still one of the strongest sources in the sky. The Eta Carina Nebula is visible with the naked eye and is a magnificent sight in a telescope. It is always worth keeping a watch on Eta Carina because it may flare up again at any time. It is highly evolved and unstable, and eventually it is almost certain to go supernova. Adjoining Carina is Pictor, the painter, originally Aquilus Pictoris, the painter's easel. Many of these older cumbersome names have been shortened. Beta Pictoris, of magnitude 3.8, is of special interest because of its planetary system, one of the first to be discovered. However, Beta Pictoris looks like an ordinary white star. The two Magellanic Clouds are sadly too far south to be seen from anywhere in Europe, but they are very familiar indeed to Australians, New Zealanders and South Africans because they are easily visible with the naked eye. They could easily be mistaken for detached parts of the Milky Way, and telescopes show that they contain all manner of objects, including variable stars and gaseous nebulae. Binoculars show these deep sky objects really well indeed. They are, of course, satellite galaxies of our own Milky Way. The Magellanic Clouds can now be seen above the southern horizon on January evenings. The large cloud lies in the constellation of Mensa, bordering Dorado, and the small cloud in Tucana, but close to the border with the nearby Hydrus star pattern. So the stars visible over Australia are just as bright and splendid as the ones seen here in the northern skies, and there are more in the way of small, unfamiliar constellations we never get to see. In the dark, arid plains of the Australian outback, where the skies are truly dark, the skies are magnificent. And while our Australian friends never get to see the Great Bear, the Magellanic Clouds more than make up for this. Their magnificence, as seen in a pair of binoculars, is something really special. That is all we have time for this month. Please visit our website, Vimeo, where you can watch all of the past shows of astronomy and space. And if you like this program, please share it with your friends and members of your local astronomical society. Until we come back in January 2016, may I wish you all a very happy and peaceful New Year. Good evening.